So this is 8.5c. These last two methods are the final two methods of factoring. Now this only works for trinomials. This is when you have a polynomial of 3. So always the first step, look for the GCF, right? And I think going through an example would just be better than me trying to explain these steps here. So scroll down or go to example 1. So I know example 1 has all of these words. I want you to kind of just ignore those words and just listen to what I'm saying and try your best to follow along. So I kind of just cleared off the words. Okay, if you need like a separate sheet of paper, you might want to do that. Now, it says factor x squared plus 7x plus 10. This is the product, which means this is the answer to some multiplication problem. Something has been multiplied. Okay. Now these right here are just talking about the coefficients. A is the first coefficient, this is B, the 7, and then this is C, the plus 10. Okay, that's all that they're referring to. Now, what they are looking for, what you are looking for is to fill these two binomials. What factor times another factor gives you a binomial? Now, here's the thing. When you FOIL, you would always do this times this, and you would distribute, right? Whatever the first one was, and then whatever the last one was, you would distribute. And that's how you would get x squared plus 7x plus 10. Okay? So, the way you find it is you have to think about the numbers 10 and 7. And positive 10 and positive 7. And so the question is, which two numbers gives you a product of 10 and a sum of positive 7? A product of 10 and a sum of positive 7. So you kind of have to know your math facts here, right? And so if you list them out, like 1 and 10 gives you positive 10, 2 and 5 gives you positive 10, that's kind of it. Right? And so which one of these two pairs, which one of these two numbers, factor pairs, gives you a product of 10 and a sum of 7? It is 2, a positive 2, and a positive 5. And so what goes in your factors is x and x plus 2 and plus 5. Now, I didn't really answer why is it x and x, because again, this is the product, right? And so when I multiply, when I FOIL it, I need to get x squared for the first one, and so that's why I have x and x. So if I were to check this, x times x would give me x squared, x times 5 gives me 5x, plus 2x, which is 7x, and then 2 times 5, which is 10. And so this checks out. Okay? So here you're looking for two numbers that multiply to 10, which is our C, and add to 7, which is our B. I don't know how many of you I got, but let's actually try a different example. Example 2 on the next page, I have x squared minus x minus 30. So this is my product. This is the answer to something, okay? So A is equal to 1 here, B is equal to negative 1, and C is equal to negative 30. Okay, again, I'm going to kind of erase all of this stuff. Okay, so I'm just going to kind of erase this up here. So again, my two binomials here, I need something times something to give me x squared. So I know for sure that's going to be x times x. Okay? Now, I need a product of negative 30, but a sum of negative 1. So let's list out all the factors that I know that will give me a negative 30. Here's a list of all the factor pairs that give me negative 30. So negative 1 times 30 gives me negative 30. 1 times negative 30. So these are all the possibilities that give me a product of negative 30, but only one of these, if I add the pair, gives me a negative 1. So I'm going to give you 5 seconds to look for which of these pairs gives you a sum of negative 1. If you said 5 and negative 6, that's good. So positive 5 and a negative 6 fits this situation. A sum of negative 30, or I'm sorry, a product of negative 30 and a sum of negative 1. So what do you do with that positive 5 and negative 6? That goes in your binomial. So it's x plus 5, x minus 6. If you need to check your answers, go ahead and FOIL that binomial, and you should get that product right there. Okay, x plus 5 times x minus 6. So this again is you're multiplying to get C, but you are adding to get B. Let's move to page 3. We'll do example 3 in a little bit, but I want to move to page 3. We're going to try doing examples 1, 2, and 3. Okay, 1, 2, and 3 here. I'll do number 1 together. Okay, so what multiplies to get a positive 2 but adds to get a positive 3? Okay, so I need my binomial. X squared is x and x again, right? That one's kind of easy. And so think about it, it needs to start with the product. What are your factor pairs that give me a positive 2? Okay, so really that's only 1 and 2, or negative 1 and negative 2. But I need a sum of a positive 3. So it's either positive 1 and positive 2, or negative 1 and negative 2. Right? But which one of these gives me a sum of positive 3? It's positive 1 and positive 2. These are my factors. Okay? Pause the video. Try number 2. Which two numbers multiply to a positive 14 but add to a negative 9? So here are the two binomials that I'm starting off with. To get y squared, I need y times y. And then here are the factor pairs. Now, I only gave you all of the negatives. How did I know that? I knew that because if I need a product of a positive 14, I know that the two symbols have to be the same. Positive times a positive gives me a positive, or even negative times a negative gives me a positive. But this middle term, when I add the two numbers, I'm going to get a negative. So that signifies to me that my factor pairs are going to be negative. Okay? So the two numbers that multiply to positive 14 and add to negative 9 turns out to be negative 2 and negative 7. Okay? Try number 3. Try number 3. If you listed out all your factor pairs and you are realizing and you're a little confused, I don't blame you, right? Multiplies to negative 12 but adds to a negative 2, right? Is there such a number? Is there even such a number? Adds to the negative 2. If you look at all the factor pairs, no, there is no number. So this doesn't work. This is a very rare case. Okay, this is a very rare case. So this actually doesn't work. What we call this is a prime number. These are prime, right? Like numbers that don't have factors other than itself is called a prime number. Okay, so that was a little bit of a trick there. Now, I know this method of factoring can be a little bit off, but you know, it's you got to look at the last number, find the product, and the sum. Okay, now let's go back to example 3. Now, the first two examples that we did, all the examples that we've done so far, this first number, this first term, didn't have anything. It was just a 1, okay? So this last method of factoring is, what do I do if I do have another number? Okay, what do I do when I do have another number? All right. Okay, first of all, what I've been saying is you need to find a GCF first, okay? Is there a GCF here? Yes, there is. It's a 3. So pull out a 3 from all of this, and so you get 3 times the leftovers, 2x squared plus 7x minus 9, okay? I'm going to kind of hold off on this 3, and it'll come back a little bit later, but I just want to focus on this guy, 2x squared plus 7x minus 9. So I'm going to rewrite that. Okay, so my A is 2, my B is 7, and my C is -9. Okay, now this is a really weird method. I'm calling this the Miller method because Mrs. Miller, who is the other teacher, discovered this. She found this somewhere. Okay, this is called the Miller method. All right, what you do in the Miller method is multiply A and C, your first and your last term, and only look at the numbers. Okay, no variables here. So 2 times -9 is -18. Okay, now from here I'm going to create my two binomials, and what I'm going to do, my first term in each of the binomials is going to be a 2x squared and a 2x squared. I apologize. It's just going to be 2x and 2x. Where is that coming from? That's coming from this. You're just going to rewrite it in both. Now, you might be saying, wait, Mr. Joe, that doesn't make sense because 2x times 2x gives me 4x squared, not 2x squared. I know, we're not done yet. Okay, it'll work out at the end. Okay, so just take your A and put it in both, 2x and 2x. Now, I want you to look at this, -18 and 7. And I want you to ask the same question, which is, which two numbers gives me a product of -18 and a sum of a +7? And I want you to put that in the blank spots in the binomial. Think about that. Which two numbers gives you a product of -18 and a sum of a +7? Let me give you 3 seconds to think about that. If you said 9 and -2, you're correct. 9 times -2 is -18. 9 plus -2 is a +7. Okay, now, here's the thing. We're not done yet, okay? If you look at these binomials, and now we have to address this issue of 2x times 2x is not 2x squared, okay? So I want you to kind of treat this like a fraction and kind of reduce a fraction, okay? Look at each binomial. Does 2x and 9, do they have can they be simplified like a fraction? No, they don't have anything in common. What about 2x and -2? Yes, you can reduce it by 2. So go ahead and reduce it. And so what happens is you have 2x plus 9, which stays the same because it didn't reduce. This one reduces by 2. And so now you have 2x plus 9 times x minus 1. If you were to FOIL this out, you would get this product right here. Okay? Now, here's a little bit of a thing though. Remember our GCF from here? We took out a 3, okay? This 3 has to come in the front because it's still part of the problem. It's still part of the factor because ultimately we need the product to be 6x squared plus 21x minus 27, okay? So this is called the Miller method. All right, go to page 3. I'll still do another example with you. Okay, so I'm gonna need a lot of room. So I kind of have the luxury of just kind of crossing it out here, whiting it out, and then just doing the work. You might have to do the work on the back or something. Okay, so I'm gonna white out number 5 and 6, and we'll do number 5 and 6 a little bit later. Okay, 2w squared minus w minus 3. First thing, look for a GCF. Take 2 seconds. There is no GCF. Okay, now I can move on. I noticed that this has something this, the first number is not 1, it's something else. So then I have to use this thing called the Miller method. Miller method, take your A, multiply by your C, and I get -6. Just the numbers, not the variables. Okay? Next step in the Miller method, make my binomials. And then this 2 comes to both. Okay? So 2w and 2w. Again, you might still be saying, wait, Mr. Joe, 2w times 2w is not 2w squared. I know. Okay? We'll reduce it at the end. Now, next step in the Miller method, look at these two middle ones. What is a product that gives me -6, but a sum that gives me a -1? Let me write that. What are two numbers that gives me a product of -6, but a sum of -1? I'm going to give you 3 seconds to think about that. If you said -3 and +2, that's good. Okay, good. Now we want to reduce these binomials if you can, and usually you can reduce at least one of them. 2w minus 3, that doesn't reduce. Okay, so I'm just going to rewrite 2w minus 3. 2w plus 2 reduces, and it reduces by 2. So I'm going to reduce both by 2. And so these are my two factors. That's the Miller method. Okay, I want you to at least try number 5. I'll bring it back up here and try number 5. Okay, I hope the first thing that you did was look for a GCF. Yes, there is a GCF. And that GCF is 2. I'm going to pull out a 2 from here. Okay? And so here are my leftovers. Now, I'm going to worry about this 2 on the outside a little bit later. Okay? But I want to do the Miller method right now. Miller method. 3 times 2 is 6. Make my binomials. 3x and 3x. And then focus on 6. So product of 6, sum of 5. That's +3 and +2. And then reduce. X plus 1 because it reduces by 3. 3x plus 2. Now, last thing, remember the GCF that came from before? Has to come out in front. And so that GCF is 2. These are my factors. Okay? Try number 6. You do number 6. I'll show you what the product is, or what the factors are at the very end, and then I'll show you the work. Here are the two factors, 5p plus 3 times 3p plus 1. If you got it, great. You can stop the video. If you didn't get it, let me show you the work. First, I looked for a GCF. No GCF. Then I multiplied A and C. I got 45. And then I put 15p and 15p in my two binomials. And then I looked for two numbers that multiplied to 45, but gave me a sum of 14. That was 9 and 5, both positive. And then I reduced, and so this one actually, both of them reduce. The first one, 15p plus 9, it reduces by 3. So dividing by 3 for both, I get 5p plus 3. And then the second group, I reduce by 5 and 3p plus 1. And so some of you now are thinking, oh, I don't have to reduce by the same number. And so these are my final factors. Some of you might really need to look this over again and watch this video. I know it was a long video, okay? But it's very important that you understand how to factor trinomials.